Thus far, we've looked at a few different things with matrices, including the dimensions of a matrix. We've added them, subtracted them, we've multiplied a whole matrix by a number. But today we're actually going to look at multiplying one matrix by another matrix. And it turns out that the dimensions are going to be incredibly important for us as we multiply matrices. So we can see that matrix A has 3 rows and 2 columns, so it is a 3 by 2 matrix. And dimension of B is 2 by 2. Now just so you're aware, there is another way that we can write this. We can write A with a little 3 by 2 down below to show that its dimensions are 3 by 2, and similarly for B. So that we do have two different ways that we can express the dimensions of a matrix. And we'll go ahead and say that we're going to make a matrix C that is equal to the matrix product we would like to compute A times B. And we're going to go through two ways of computing a matrix product. So there will be two different algorithms. You can choose whichever one you prefer. But we'll go through a whole example with the first method first. And the way that we're going to do these matrix product is we're going to take a row from matrix 1 and we're going to multiply that by a column from matrix 2. So in order to create my entry C11, what I'm going to do is I'm going to multiply the 2 from my first matrix times the 2 from my second matrix, and to that I'm going to add the product of the negative 3 from my first matrix times the negative 3 from my second matrix. So I will end up getting here that's 4 plus 9 is equal to 13, and that's going to be my entry C11. Now similarly for entry C12. C12 will have me taking the first row from my first matrix, multiplying it now by the second column from my second matrix. And so what I will get, I will have my 2 again, this time times the 1 from the second matrix, and to that I will add the negative 3 from my first matrix, times the 8 now from the second matrix, which is going to give me 2 minus 24 is going to be negative 22. And so I'll put my negative 22 right here. And I'll start going a little faster now. Second row from my first matrix, first column from my second matrix. 0 times 2 plus 1 times negative 3 is going to be negative 3. C22 will have second row, second column. We'll get 0 times 1 plus 1 times 8 is 8. C31, we're going to have 5 times 2 plus negative 8 times negative 3. That's going to be a positive 34. And C32, we are going to have third row, second column. We're going to have 5 times 1 plus 8 times negative 8. And that's going to be, let's see, negative 59. Now that we've done this multiplication, I want you to take note of a few special factors about what we did. Notice how it was important that we had two numbers here to match up with two numbers here. That's the number of columns in A, if you look over here to the right, number of columns here in A had to match the number of rows in matrix B, which if you take a look here at dimensions, here's the 2 columns from matrix A, matching up with the 2 rows from matrix B. And also note that matrix C has dimensions 3 by 2, which those are what we have right here, the 3 and the 2. So this will always be the case, that we need these 2 dimensions here to match up, and the result will have these dimensions here. So here we are again with 2 matrices we'd like to multiply. Hopefully these look awfully familiar because they're exactly the same matrices that we used in our last example. But this time I'm going to try to define a matrix product D that's equal to B times A. And so we start by trying to do a computation for D. And so we go and we say, okay, we're going to take the first row from matrix B, multiply it by the first column from matrix A, and so we say, okay, D11 will be equal to 2 times 2 plus 1 times 0 plus, we've got a problem because we've got nothing here to multiply by the 5. So as you can see, we actually can't do this product. So the multiplication for matrix D can't be done, so we've got no solution here. And if we'd written out the dimensions of the matrices again, we could have seen this right from the beginning, that B is 2 by 2, A is 3 by 2, and since these 2 dimensions here don't match up, we know that we're not going to have a solution. So matrix multiplication has this interesting property that we just did the matrix product A times B, but in this case it's not just true that the B times A was different, we weren't even able to compute it. So you need to remember, A times B and B times A are not going to give you the same result when we're multiplying matrices. So it's very much unlike the normal numbers we're used to working with in that way. Now here we're going to look at a second way of computing a matrix product. Now you can see that these are the same matrices we've been working with so far. Here's matrix A, here's matrix B, and I'm going to provide a space for matrix C right here. And we're going to go ahead and try to do this multiplication. So first row times first column, we would get 2 times 2 plus negative 3 times negative 3 gives us positive 13. And the nice thing is that this shows us right where it belongs. These are matching up right there. And we can carry on with this computation. This row times this column is going to give us 2 minus 24 is negative 22. Here, this row times this column is going to give us a negative 3. This row times this column is going to give us a positive 8. This row times this column will have 10 plus 24, 34. And this row times this column will have 5 minus 64 is negative 59. And we've gotten the same result as we got earlier, which is good. So both results or both methods are giving us the same result. Again, you can use whichever method you prefer. So here we've got a square matrix A, which is 2 by 2, and we're going to look at what it means to talk about A squared. Now the first thing I'm going to tell you is what this is not equal to. And even though I'm telling you now it's not equal to this, I can almost promise you on a test somebody will do the following. They're just going to take matrix A and they're going to square every entry. So they'll have 9, 1, 16, and 36. And this is definitely not what we're talking about when we talk about squaring a matrix. We don't ever have a need of squaring every entry in the matrix. When we talk about squaring matrix A, we're saying take matrix A and multiply it by matrix A. And I'll go ahead and set this up using the second method, which really is my preferred method of multiplying matrices, where we've got negative 3, 1, 4, 6. And the same thing up here, negative 3, 1, 4, 6. And so for our product, we'll have, let's see, that's going to be 9 plus 4 is 13. We'll have negative 3 plus 6 is 3. We'll have negative 12 plus 24 is 12. And we'll have 4 plus 36 is 40. So there is our matrix A squared. And we could also similarly compute the matrix A cubed, which would be equal to A times A squared. So we'd have to do A squared first, and then we could take our matrix A, -3, 1, 4, 6, and we could multiply that by 13, 3, 12, 40. And I won't go through that computation, but that's what we would do if we wanted to compute A cubed. And by the way, this is one case where it doesn't matter whether I do A times A squared or A squared times A. We're going to come out with the same thing. But this is a special case, and in general, matrices cannot be multiplied in whatever order you care to. So for class tomorrow, please take a look at these following three matrices, and I'm going to ask you to compute A times B, B times A, B squared, and B times I. Note that not all of these are necessarily going to have solutions, but go ahead and do these computations. I will see you then.